Let's do another problem from section 4.4 in your lab. They want us to find the limit, and they're taking the limit as x approaches 0 of cotangent of 3x times the sine of 9x. So cotangent is cosine over sine, and the cosine of 0 is 1, but the sine of 0 is 0, and that's in a denominator. So that's going to give us an infinity for the first term, and sine of 0 is 0. That's going to give us a 0 for the second term. So this is an indeterminate form, and it's a form of infinity minus, or infinity times 0. So now if we just change the expression, the cotangent can be written as cosine over sine, or 1 over tangent, I suppose, if that's what they're going for. I probably would have wrote it as cosine over sine, but in this case they had a 1 in the numerator, so it looks like they want us to write 1 over tangent. And so now if we look at this expression as a sine over the tangent, then we have an indeterminate form because the sine of 0 is 0, the tangent of 0 is 0. So we have a 0 over 0 form, and now we can take the derivative of the numerator and the denominator. So the derivative of sine of something is cosine of something times the derivative of the inside, which is going to be 9. Derivative of tangent. So if we remember the derivative of tangent, I think that's a secant squared. So let's see. I might need to stretch this out so I can see what I'm doing. So secant squared of 3x, again, times the derivative of the inside, which is 3. So we have that. The derivative via L'Hopital's rule is going to give us this, and cosine of 0 is going to be 1, and then that's 1 times 9. Secant is 1 over cosine, so secant squared is 1 over cosine squared, but if we put 0 in there, this is still going to be 1. So 3 times 1 is just going to be 3. So our fraction is no longer 0 over 0 or infinity over infinity. So the limit here is going to be 9 divided by 3. I suppose we should simplify that. But let's see if they take 9 divided by 3. Okay, so that worked out okay. And this is the final answer. So the limit of our original problem is going to be 3. Okay, hope that helps.